Today we will study the atom. Firstly, lesson objectives. What are those? What we will study today? First, the atom. What is that? Particles. After that, atomic theory. Then electrons, nucleus, protons, Bohr model, neutrons, and electron cloud. One by one we will study. The Greek philosopher Democritus thought matter could be divided into smaller units until you obtained a particle that could not be cut. Actually, you see here, we can cut one matter many times, for example, 100 times, maybe million times, maybe we are able to cut it, but there is a limit. After one limit, we are not able to cut it. Okay? He called that particle, which is not able to be divided, is atom. Okay? It comes from the atomos, the Greek word actually. Okay? Scientists have come to agree that matter is made up of small particles, and they use the term atom to describe them. Okay? The particle, which is the smallest particle in the matter, is called atom. Now, the atom is the smallest particles into which an element can be divided and still have the same element. You see, it is the still same element. You know, one element, for example, iron, can be divided into many pieces, and you may produce the iron fillings. Okay, but the small particles inside it are called atoms. They are again that element. Okay, they belong to that element. Again, they made the same reaction with other elements. Okay, how about the smaller subparticles inside of the atom? So, for example, proton, neutrons. They are not actually the smallest particle in the atom. We are not able to call it unit of the element, right? Why? Because they don't have the property of that element. Okay, let's continue. Scientists now know that atoms are made up of smaller particles, but the atom is the smallest unit that has the chemical properties of an element, as I explained before. Okay, the chemical properties of the elements can be seen on the one atom. The smaller particles, we call them subparticles, inside of the atom are not able to show, chemical property of it. There are many types of atoms that combine in different ways to make all substances. You see here, many matters are present, many substances are present around us. Some of them are plastic, some of them are, alive organisms, some of them is made up of, for example, fabrics, whatsoever. All of them are made up of atoms, but the combination of the atoms, the property of the atoms are different. That's why they are all in different structure. Who developed the atomic theory? In 1808, John Dalton published an atomic theory stating that all matter is made up of atoms that cannot be created, divided, or destroyed. This theory also stated that all atoms of a certain element are identical, but they differ from atoms of all other elements. Till now, you see, atoms cannot be created. Still we couldn't create any atoms, but as a theory, from energy to the atom, some production can go on according to Einstein, but it cannot be divided or destroyed, they said, but it can be destroyed and divided now. Okay, this theory also stated what all atoms inside of the one element are identical, but those atoms are different from the atoms of the other elements. Okay, each element has different atoms. Every substance is made up of atoms combined in certain ways. You see, each and every substance in our environment are made up of atoms and they combine in different ways. You know, even same atoms in different substances can combine in different ways. You know, the molecular structure can be different from one material to another. That's why the materials are different from it. After that, J.J. Thomson in 1897, he provided evidence that atoms contain negatively charged particles which are called electrons. And he thought that electrons and the protons are mixed inside of the atom. Okay? Who discovered the electrons? Thomson. In 1909, Ernest Rutherford's experiment suggested that atoms have a nucleus, a small, dense center that has a positive charge. Rutherford later found that the nucleus is made up of smaller, positively charged particles that he called protons. Ernest Rutherford discovered the protons in the center of the atom, in the nucleus. He also mentioned the nucleus firstly among all those scientists. Okay? Electrons are revolving around one nucleus, and there is a proton inside of that nucleus. Niels Bohr suggested a model in which electrons move around the nucleus in circular paths, with each path at a certain distance from the nucleus. You see, he suggested that nucleus in the center of the atom, and it is surrounded by the electrons, and in each path around the nucleus there is an amount of electrons for each circle, for each path. Okay? For example, here you are able to see in the first path there are just 2 electrons. You see here in the second one there are 6 electrons. Actually, there are not 3 electrons in the first path, because in the first path he says maximum 2 electrons can be present. Okay? After that, in 1932, James Chadwick discovered that the nucleus contains uncharged particles called neutrons. Here, you see, first of all, protons are discovered. Now, neutrons also discovered by Chadwick. In the current atomic theory, electrons do not move in the circular path around the nucleus as Bohr thought. In the Bohr model, it is the Bohr model, we knew that electrons were actually circulating, revolving around the nucleus in the circular path. But after that, in the current atomic theory, instead, the current theory suggests that electrons move within an area around the nucleus called electron cloud. They said that nowadays they say, electrons actually revolve around the nucleus of the atom in random way, in the random path. They move randomly, okay? And we are not able to state the speed and status of the electrons once at a time. That's why we are not able to see its position and speed. That's why it is said that there is an electron cloud around the nucleus. Okay? Here there is a video about atom. Let's watch it.
Each atom has a dense center called a nucleus. The nucleus contains neutrons, which have a neutral electric charge, and protons, which are positively charged. The number of protons in an atom determines an element's physical properties. No 2 elements have the same number of protons. Revolving around the nucleus like planets around the sun are negatively charged particles called electrons. Electrons and protons attract each other, so atoms usually have equal numbers of the two particles.
Over time, microscopes have become more and more powerful, allowing us to see deeper into the world of the ultra-small. Traditional light microscopes can be used to see things like these onion cells and the structures within them as they divide, pulling apart their chromosomes. But scientists have come up with a whole host of clever methods to observe far smaller things. Using beams of electrons instead of light, we can generate detailed images of chromosomes themselves. Recently, groups of scientists around the world are becoming able to see materials at the most fundamental scale, the atomic. One group from the University of California in Los Angeles have been getting up close and personal with nanoparticles of platinum, just a few nanometers across. Each of the tiny dots you can see here are actually individual platinum atoms. But researchers didn't stop at a two-dimensional picture. By imaging over 100 slices of the nanoparticle at different angles, then removing the noise with a special filter, they were able to map the location of almost every atom. The information was used to create a three-dimensional reconstruction of the whole particle in unprecedented detail. It may look blurry, but this particle is estimated to contain over 27,000 atoms, and so, like flies in a swarm, they appear to merge together. Every so often, though, we see the platinum's atomic structure align, granting us a moment of clarity. This technique is being used to analyze tiny irregularities in the structure of the particle called dislocations. Dislocations are subtle, like the misalignment of the green and red layers of atoms in this particle. But nonetheless, they can significantly change the properties of materials, with effects ranging from a change in the efficiency of LEDs to the strength of metal alloys. Three-dimensional atomic-scale imaging like this is bettering our understanding of the structure of materials on this truly...
Okay, as you see here, before we were not able to actually see the atoms. Nowadays, thanks to technology actually, we are able to see the atoms nowadays. Okay, but the electrons in the atoms still are not able to be detected. Okay, we are not able to see it. Okay, in the previous video also she mentioned that there were neutrons. Neutrons, actually neutral. They don't have any charge, right? But the protons has the charge. Okay, positively charged. Electrons has negatively charged. Actually, these all